All right, so pretty cool conference so far. I hope you're having a great time networking, learning stuff, getting super excited about data and AI. All right, so here's like the obligatory slide. I don't think I have any forward-looking statements, but if I do, take them with a grain of salt, subject to change, et cetera, et cetera. For the sessions y'all have been attending, is everyone doing this for every session you attend, these ratings? Because I don't know if you've realized it, but like at Databricks, we're a bit obsessed about data. So like, please feed us the data. So I'm a specialist solution architect at Databricks. Oh, hopefully nobody has epilepsy. And I help clients. I'm sort of a wingman to the essays, and I help with special architecture planning or sometimes deep dive optimization, and then I get to help do talks like this. And today we're going to just talk about some recent improvements to the State Reader API. And has anyone used the State Reader API yet? No. Okay, cool. Maybe, kind of, 0.5. So today's talk is on the, like a new addition to it. We'll review like the State Reader API basics. But before we do that, I want to use our imagination a little bit. Like we're indoors in this conference center, and like I prefer to be outdoors personally. So we're going to use our imagination. We're going to pretend that our work involves the outdoors. So we're going to imagine that we work in the wildlife management sector. So in the United States, there are about 1,200 species of freshwater fish, and many of them can be found in rivers. And our job is to help ensure the health and continuation of various species, right? So we're going to look at how Apache Spark's stateful structured streaming can help. And during the development of our stateful streaming application, we'll see how the State Reader API's change feed can help with development, debugging, and troubleshooting. So Databricks is a great place to run streaming workloads. In the early days of Apache Spark, that wasn't its main bread and butter, but in the early days of Databricks, you could say our bread and butter wasn't warehousing, but we've come up to speed and surpassed many capabilities, and I think when it comes to streaming workloads, this speaks for itself. And with Apache Spark 4.0, stateful streaming is greatly improved. So stateful streaming, the new stateful operator is called transform with state. If you've used the previous stateful operator, which was apply in pandas with state or flat maps group with state, you could kind of do what you needed to do, but it was painful. It was not super efficient. So our exploration will involve we'll touch on that a little bit, but I recommend looking into the other sessions that cover transform with state, or just search it. We have some blogs and stuff on it. All right, so back to our mission. So our mission is to alert wildlife managers when interventions are needed to maintain optimal fish populations and health. So we want our system to dispatch wildlife and fisheries experts into the field to apply a variety of measures to help the fish. So egg distribution, fish stocking, et cetera. And so for instance, we want to generate an alert if there's an imbalance in the distribution of sex for a certain species, which could impact future fish stocks. So you need a good ratio of males and females to ensure future generations can thrive. And so this is a perfect match for a stateful streaming pipeline. So in our use case, this sort of made-up use case and made-up Gen AI image there. Imagine that we have hundreds of IoT sensors monitoring fish movements across various river segments. Now, our sophisticated IoT sensors can detect species, size, age, and sex of each fish. So with potentially millions of data points per second arriving continuously across all river segments, we can use structured streaming to optimize the data processing and parallelize the computations across the Spark cluster. All right. So Raise your hand if you've been using Apache Sparks for less than 2 years. All right, so we got a couple folks here. So that's good, because we're going to want to just review some structured streaming concepts before we go on. And it can get sort of really confusing. For instance, yeah, it looks fine. So the first concept is partitions. And this can be really confusing because the source system that you connect to may have partitions of its own. So if you know Kafka is composed of one or more, Kafka topic is composed of one or more partitions. And if you know Kinesis, a Kinesis stream is composed of one or more shards. So in the source system, that partitioning is sort of one concept. That's one partitioning scheme. But then there's Spark that has its own concept of the input partition, and the mapping from the source to Spark isn't always one-to-one. So for instance, if you're using Kafka, there's an option called min partitions that allows you to have a single Spark input partition reading from multiple Kafka partitions. All right, so, and in the rest of this talk, neither of these partition concepts are what we're going to talk about. There's this other partition concept, which is spark.sql.shuffle partitions. Does everybody know that configuration? Yeah, if not, it's a good one to just become familiar with. So when data is organized based on keys for wide transformations, such as aggregations or group bys or joins, shuffle partitions come to play. So a stateful stream's number of partitions is also configured by that spark.sql.shuffle partitions. So that's something that's important to know, especially if you're working at massive scale. And the default is 200. So you can think of that as the number of grouping buckets that helps the correct keys get distributed to the correct executor or worker node. And again, so for the rest of our talk, we'll be focusing on that concept of shuffle partitions, because in a stateful stream, that's a mechanism for parallelizing across the keys. And bear with me, I've got more comments that I need to, there we go, scroll a little bit. All right, and then these next concepts I'll go through fairly quickly, but they're worth learning, especially if you have something at scale, or if you're using that custom PySpark data source that I mentioned earlier. These concepts are pretty important. So offsets. This is a to-do list, so this is like the Spark offset, so it actually can still be confusing because Kafka has its own offsets. Spark has its own offset concept when it comes to micro batches. So when you're streaming in Spark, it's doing these little pulses of processing, and each micro batch has an offset number. If you've ever looked in the checkpoint directory, so if you have a stream and you're persisting it somewhere, you have to specify a checkpoint directory, and we're going to look at that in a little bit. That's where you can see sort of the batches, and then within that, it may contain the offsets related to the source system. So it can be confusing, but in most cases, you don't have to necessarily worry about the contents of the checkpoint directory. But for large streams, sometimes knowing these little details can be handy. There's also another directory in the checkpoint directory called offsets, called commits, and this is sort of the done log, or the, just after a microbatch is processed and successfully written to the sink or destination, the batch ID will be written to the commit log, and this is helpful, like if a job fails and has to restart, it's going to check this commit log to see if it has to basically reprocess the previous microbatch. And so it's essential for job level fault tolerance and exactly once processing. All right, so that's a little bit of background. We understand our mission. So for those partition concepts, we could potentially partition our inbound data on river segment, or maybe river segment and species. So with transformer state, and with the previous stateful operator, your key can be a sort of a composite key. And And then since our IoT sensors include some onboard memory, I don't know if you noticed it in the little picture there, that onboard memory might have some historical data. The timestamp field is something that we could potentially use as the offset, like the source offset. Cool. So now these other concepts are sort of relevant to stateful streaming. So Apache Spark is a micro-batch processing engine, operates on a small batch of records at a time, and in our fish monitoring use case, we need to maintain some state across those batches. So if we capture a sliding window of 6 hours of fish data, so remember we want to see if there's going to be sort of future populations, are enough females and males sort of swimming by. If you want to capture like a sliding window, you're going to need some stateful data captured. So the state store serves as that set of, like, think of it as mini databases. So it's backed by RocksDB, and that's actually a configuration you have to set. It's not the default. But those are essentially mini databases that are distributed across the workers. And for each microbatch, some data is persisted to cloud storage as well to ensure durability and fault tolerance of the stream. And when we look at the directory, we see there's a commits and offsets related to the microbatch level. And the state directory is a little bit more complex. There we go. My laser pointer's not very bright. But you can see the directory structure is a little bit different than the commits or offsets, right? So there's a subdirectory for each stateful operator, and then subdirectories underneath that for each partition of data. Yeah, so these are sort of the concepts that are useful. And now we're going to review the state reader API sort of original features. So this talk is eventually, I'm going to have to speed it up, but eventually we're going to get to the change feed. But we're going to review like the initial state reader API. And the state reader API has sort of two formats. So if you see the spark.read.format, the first one we'll talk about is state metadata. But draw your attention to the right-hand side. So that's sort of the code associated with what's stored in state. So we can see we have two chained operators here. So two stateful operators are chained together. And we can see them in the results here. So the nice thing about this state reader API is it's just another Spark format. And then once you load it, so you load it from the checkpoint directory. And then once you have that, you have your data frame. And again, this is spark.read.format state-metadata. And this is just the high-level stuff. So we get fields for number of state partitions, the batch IDs, and what else do we have there? Yeah, the min batch and the max batch ID. So when it comes to the state store iterations, so the Apache Spark is running these microbatches. All those microbatches have a batch ID. There's only 100 sort of state store history changelogs maintained. Let's see what else here. 100, yep. Yeah, and there's 100 sort of historical versions of state kept because you don't want your state to grow unbounded forever. And there's also a snapshot, which we'll get to in a little bit, that can be used. So if you have to restore your stream, it will process change logs, but if there's a snapshot, it'll use that and then process any change logs after that. So again, we see here we have two stateful operators spread across 8 partitions, and the state store name or the operator name the state store name in this case is just default. So if you have a stream-to-stream join, you'll see an indication of which is it the left or the right side of the stream-stream join. But in our case, it's just a straight sort of transformation. And since we're using transform with state, we see that here, and then there's a little bit of extra data that we won't necessarily have to worry about here. And then the other state reader API format is just called state store, so state or spark.read.format state store. The state store format helps us peek into the actual contents of the state store. So this is not the output of the stream. This is the content of those mini databases that hold that intermediate data for your stateful stream. So this is like the knowledge that's needed, in between your inputs and output. So it's the contents of what's in RocksDB, if you will. And so looking at this, it looks fine, right? So the code looks good, the state store data looks good, but this is hiding a bug. So there's a bug in my transformer state logic that if I were to just use this state reader API in development and debugging, which is one of the main sort of purposes of it, I wouldn't spot the bug. And we'll get to the bug in a minute, or 3 minutes. So today we're talking about the state reader API's change feed, and that lets you look at the changes over time over the course of batches. So here, really the only difference is I've added this read change feed, and I've told it what batch I wanted to start to read at. So you can see, so sort of the cool thing is in my stateful operator, in my transformer state logic, I've got a composite key, species and river segment. I've got a map, and I thought I had another state. Oh, that's right. So there's an option. So in transform with state, you can actually have multiple named state variables. And so when you look at the state reader API, you provide the, the name of the state variable. So the bug here, which is kind of hard to see, so this is supposed to be a change feed, but when I look at this, I see the same key has a number of updates to the state store for the same batch ID. So that means my stateful operator is inefficient. So ideally, so even though the state store is fairly efficient to update, every update you do to the state to the state value will be noted in the change log. So sort of the highlight of this talk is really that the change feed, when you're debugging or troubleshooting, can help you see errors like this. So that there is what smells funny if you don't see it. So for the same key of my state variable, I really should be updating it once. Like that would be the most efficient way to go about it. And this is the code. So this is I'm not going to go through all this code, but as I look through this, I see, oh, I'm updating the state variables within a loop. So every time my stateful operator has to process a micro batch of rows for a given key, I'm looping through and I'm updating state. So that's not great. So I don't have time to go through the live demo, but one thing I want to point out is this state store change feed, don't confuse it with the delta change feed or CDC or SCD. So it's not intended to be used like that. That state is not something that you can stream off of. So it's only a spark.read.format state store. There's no support for the read stream. But you can still use that state store API or the state reader API to run queries, and those queries can be used to populate dashboards. There's one other feature that you probably will never need. It allows you to read the snapshot file. So I'm talking about these change logs here. There's also a periodic, like, full snapshot of what's in state that gets synced down to cloud storage. You can use this snapshot start batch ID, snapshot partition ID, and you can basically have it ignore subsequent snapshots, and it'll just basically start at a snapshot and then use the change logs. Again, this feature you should never need. This is like really intended if you suspect there's something wrong with the snapshot version of state, and you want to go, yell at us that there's a bug. This would help give you evidence, like, hey, I can bypass this snapshot and get a different outcome. So this was probably developed as they developed, the state logic, but for your purposes, probably never need it. So, again, we love data. We're hungry for feedback. Help us make the future sessions better. And so the change feed, and it's just one option in the state reader API, option read change feed true. Helped us find a performance bug in our stateful operator during development. And so you can see how this could probably be used for production troubleshooting, development, et cetera. Like previously with the previous stateful operators and pre-Spark 4.0, you would have had a lot of like print logic in your stateful operators, and it'd be pretty gnarly because you couldn't get to the state. So this state reader API lets you peek into those mini databases that store that sort of intermediate data. And that's it. Thank you for the time.